Welcome to Capital Decisions Part 3. By the end of this ACLET, you should be able to use NPV to help decide yes or no for a capital decision involving uneven cash flows and a residual value. Here's the situation for NPV Example 2. Harborside Hospital is thinking about buying an X-ray machine for $1,250,000. The residual value is $20,000, which means that at the end of the equipment's useful life, we would expect to sell the machine for $20,000. The useful life is 6 years, minimum required rate of return is 10%, and expected cash flows for each of the 6 years are as displayed. We'll use a table to organize our data for calculating the NPV of this potential investment. If we invest in the equipment, the first cash flow would happen at the beginning of year 1. $1,250,000 cash would go out, so we'll enter the amount as a negative number. Since the cash is changing hands today, day 1 of year 1, there is no interest in the $1,250,000, so we don't need to use a present value factor to remove any interest. $1,250,000 is the present value, and again, because the cash is going out, we enter it as a negative amount. As in example 1, the incoming cash flows occur in the future, so each cash inflow amount has interest in it, which we need to remove so we can compare the cash outflows to cash inflows without interest clouding the picture. When you look at the expected cash inflows, notice that while the first two amounts are the same, $300,000, the other amounts vary. So when we use present value factors to remove the interest from the cash flows, we could use an annuity factor for 2 years, but then we'd have to use factors for single deposits for the other 4 cash flows, so it might be simpler to use the single factors for each of the 6 cash inflows. The first cash inflow will occur at the end of year 1. Because the cash is coming in, we'll enter the amount as a positive number. Since we don't have an annuity for the 6 years, we'll use the present value table for single deposits. The $300,000 will come in at the end of 1 interest period, and the interest rate per interest period is 10%. The present value factor is 0.9091. Multiply the cash flow amount, $300,000, by the factor, 0.901, and the present value is $272,730. The difference between the $300,000 and the $272,000 is interest. 1 year's interest at 10%, which we just eliminated from the cash flow. The second cash inflow will occur at the end of year 2. $300,000 incoming, we enter it as a positive amount. We'll use the present value table for single deposits. This $300,000 will come in at the end of 2 interest periods, 10% per interest period. The factor is 0.8264. Multiply the $300,000 by the factor, and we find that the present value of the second cash inflow is $247,920. We'll do one more cash inflow to make sure you have the pattern down. The third cash inflow will occur at the end of year 3, $250,000. We'll use the present value table for single deposits. The third cash inflow will occur at the end of 3 interest periods, 10% per interest period. The factor is 0.7513. Multiply the cash inflow amount by the factor, and the present value is $187,825. You might want to pause here and figure out the present values of the next 2 cash flows, then compare them to the results that follow. The present value of $300,000 to be received at the end of year 4 is $204,900, and the present value of $250,000 to be received at the end of year 5 is $155,225. Before we move on, notice that 2 things will happen at the end of year 6. We are expecting to receive a cash inflow of $300,000, and we are also expecting to receive an additional $20,000, the residual value. This is the amount we expect to receive when we sell the equipment when we're finished using it at the end of year 6. Since both the final $300,000 and $20,000 cash flows will occur at the same point in time at the end of year 6, we can combine them. We use the present value table for single deposits at the end of 6 interest periods, 10% per interest period. The factor is 0.5645. Multiply the cash inflow $320,000 by the factor, and the present value is $180,640. Now you can add the amounts in the present value column, paying close attention to whether the amounts are positive or negative. You should find that the total is a negative $760. So the NPV of this investment is negative $760. Should Harborside invest in this equipment? No, because NPV is negative, which means that the rate of return on the investment would be something less than 10%. Because the amount of the negative NPV is very small, Harborside's rate of return would be just under 10%, in fact very close to 9.98%. The 9.98% return that Harborside would earn if it invested is the internal rate of return, the IRR. If we calculated the NPV using the interest rate of 9.98 instead of 10, the NPV would be 0. So another way of thinking about IRR is that it's the interest rate that results in 0 NPV. This concludes the ACLET Capital Decisions Part 3.